કેમ છો વિદ્યાર્થી મિત્રો? આપ સર્વે ઘરે સ્વસ્થ અને કુશળ હશો. સમયની બદલાતી માંગ સાથે આપણે પણ ચેન્જ થવું પડતું હોય છે. આ હેતુથી આપણે આ કોરોના જેવી મહામારીના સમયની અંદર તમારો સિલેબસ કમ્પ્લીટ ચાલે, અધૂરો ન રહે તેવા હેતુથી આપણે આપણો અભ્યાસક્રમ છે એ ઇન્ટરનેટના માધ્યમથી આપણે ચાલુ કરીએ છીએ. આપ સર્વેને સિલેબસની કોપી તો મળી ગઈ હશે. ભાઈઓ અને બહેનોના બંને ગ્રુપમાં મેં સિલેબસ છે એ મોકલી દીધો છે. એટલે આપ સર્વે જાણો છો એ પ્રમાણે આપણે સેમેસ્ટર 5ની અંદર મેઇન સબ્જેક્ટના 5 પેપર ભણવાના છે અને એ 5 પેપર પૈકીનું આપણું જે નંબર આપેલો છે IC-B-506 સિન્થેટિક ડ્રગ્સ, આખું ડ્રગ્સનું પેપર છે. એનો અભ્યાસ આપણે આ પેપરની અંદર કરવાનો છે. તો આપ સર્વે ઘરે સ્વસ્થ અને કુશળ છો ત્યારે આપણે આ ઇન્ટરનેટના માધ્યમથી આપણો સિલેબસ છે એ આગળ ચલાવીએ. એકોર્ડિંગ ટુ our syllabus, paper number 506 is divided into 4 units and each unit contains equal marks and equal teaching hours. First of all, we start our unit number 1. Paper number 506, unit number 1. First of all, we see the meaning of drugs. What is drugs? The drug is word derived from the French word drogue, which means dry herb. The drug may be defined as a substance used in prevention, diagnosis, treatment, or cure of disease in man or other animals. According to WHO, World Health Organization, a drug is defined as any substance or product which is used or intended to be used for modifying or exploring physiological system or pathological states for the benefit of recipient. An ideal drug must have specific localization action and must be from side reaction and adverse effects. Pathogen should not develop resistance very easily toward a such drug. However, in practice, no drug function as ideal drugs. According to our syllabus, in Unit 1, first topic is anti-malarial drugs, and in this class we studied 3 components: chloroquine, primaquine, and camoquine. In this lecture we studied only component 1 or chloroquine. First of all, we see the anti-malarial drugs introduction. So, what is the anti-malarial or malarial? The word malaria is derived from Italian word mal means bad and ria means air. That means the bad air. For a long time, it was believed that malaria was caused by a miasma the words, which arise from stagnant water at night. Night air was thus regarded as bad. Ronald Rose, the name of scientist, Ronald Rose, in 1897 demonstrated the presence of malaria parasites in the wall of stomach of female Anopheles mosquito, which lives in the damp regions. Thus, a rational explanation was given for earlier belief that malaria arises from swamp and stagnant waters. By the close of 19th century, the two cycles of malaria parasite, one in man and other in mosquito, were clearly established. The genus Anopheles is a large one. However, its four species, namely Plasmodium vivax, Plasmodium malaria, Plasmodium ovale, and Plasmodium falciparum, are responsible for malaria in a man. Malaria is a widespread disease and lakhs are infected every year and thousands die of it. Today's situation, we do not remember this infection and die of any men or animals. The bark of cinchona tree, this is the tree, cinchona. The bark of cinchona tree, which contains quinine, remain a drug against malaria for nearly a century. Quinine is the drug which prevents from malaria. At present, natural as well as synthetic drugs are used to fight this disease. Quinine is natural component and according to our syllabus, chloroquine, primaquine and chromoquines are the synthetic drugs which is used against the malaria disease. Now we saw first compound is chloroquine. Chloroquine is synthesized in a two parts. First of all, we synthesize compound A and compound B. After we synthesize component 1 and component 2. After component 1 and 2, condensation gives our main product chloroquine. So we start synthesis of chloroquine. The component A is synthesized in the chloroquine. Component A is synthesized from two raw materials, ethylene oxide and dioxide. Here, both structure of raw materials are described here. Ethylene oxide is triangle component and diethylene oxide is straight component which is reacted to each other give first step of the component. Interaction between ethylene oxide and diethyl oxide gives OH, CH2, CH2 and C2H5 twice. Its name is 2-diethyl aminoethanol. This compound is 2-diethyl aminoethanol. After 2-diethyl aminoethanol, this compound was reacted with SOCl2. So, in a compound A, the OH group is converted into chloro group. OH group is converted into chlorine group. So we get compound A and it is known as 2-chloro-triethylamine. 2-chloro-triethylamine. Then for compound B, CH3CO, CH2, COO, C2H5. It is known as acetoacetic ester. Acetoacetic ester. It is reacted with sodium ethoxide C2H5ONA gives compound B. Compound B. Above we synthesize component A and here component B. So next step, compound A and compound B both are reacted, gives the first step of this reaction. Next, this compound was hydrolyzed with the help of ethanol. It is known as ketonic hydrolysis. Ketonic hydrolysis. On ketonic hydrolysis, give the this product. Give the this product. This product is known as 5-diethyl amino 2 pentanone. 5-diethyl amino 2 pentanone. After the compound 5-diethyl amino 2 pentane was reacted with some reductive component, as for example hydrogen, ammonia, nickel, gives the next component. This component is known as, for this synthesis, compound 1, and this compound is known as 5-diethyl amino 2 aminopentane. 5-diethyl amino 2 aminopentane. After this, for synthesis of compound B, we have two raw materials. One is ethyl acetate and second is diethyl oxalate. Ethyl acetate and diethyl oxalate are reacted in presence of sodium ethoxide. Sodium ethoxide. This is the sodium ethoxide and ethanol C2H5OH gives the ester group derivatives, and these derivatives are reacted with Ca3COOH, means acetic acid, gives the next ester group derivatives, and these derivatives are rearranged. This one and this one both are known as oxyl acetic ester. These oxyl acetic esters are reacted with metachloroaniline gives the compound. This compound is also a ester derivatives. After this ester derivatives is reacted with ethanol at present of 250 degrees Celsius, and then we get this compound is known as ethyl ester of chlorohydroxyquinoline 2 carboxylic acid. Chlorohydroxyethylene 2 carboxylic acid. And this compound are rearranged. Ethyl ester of chlorohydroxyquinoline 2 carboxylic acid rearrange at this type of structures. Now this ethyl ester of chlorohydroxyquinoline 2 carboxylic acid was hydrolyzed. So ester components are removed. Here COOC2H5 was removed by hydrolysis, and then the compound is reacted with, this compound was reacted with POCl3, gives the 4,7 dichloroquinoline, 4,7 dichloroquinoline. This is our component 2. Now, component 1 and component 2. Here describe both component. Component 1 and component 2. This is 1 and this is 2. Both are condensate together and we get our final component. It is known as chloroquine. Chloroquine. Now, the uses of chloroquine. It is used in form of its hydrochloride for injection and in form of sulfate or phosphate to prepare tablets. So it is available in injection and tablets. It is 3 to 4 times more effective than quinine. Quinine is natural component and our chloroquine is synthetic. So it is 3 to 4 times more effective than quinine. It is highly effective against vivax and falciparum malaria. We saw 4 parasites of malaria and it is chloroquine is highly effective pro vivax and falciparum. Next, it has a number of side effects such as general weakness, uneasiness in epigastrium, loss of appetite, vomiting, diarrhea, and occasional insomnia. However, these symptoms tend to disappear as soon as the use of the drug is stopped. Here we stop our this lecture and next two components primaquine and chloroquine are we study in next lecture. Thank you.